सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
Mathematical structure of quantum theory reconstructed from information principle. Scientists have found the theoretical rationale of the mathematical structure of composite quantum systems consisting of more than one subsystem. Quantum mechanics, the theory that describes physical phenomena in microscopic world, was developed in the early 20s to explain experimental observation like blackbody radiation curve, photoelectric system from German physicist Max Planck, demonstrated through physical experiments that energy in certain situation can exhibit characteristics of physical matter. Later, scientists like Albert Einstein, Niels Bohr, Louis D. Broglie, Erwin Schrödinger, and Paul M. Dirac advanced Planck theories to quantum mechanics, the most accurate mathematical theory of the microscopic world. Unlike other physical theories that are built upon physically motivated postulates, quantum mechanics starts with abstract mechanical axioms. For instance, the second postulate of special theory of relativity says that no information can travel faster than light, whereas quantum mechanics starts with the axiom that state of a physical system is described by a vector in complex separable Hilbert space. To strive, yearning for a better physical understanding, scientists are still pursuing their endeavor to rederive the mathematical structure of the quantum theory. Starting with physically motivated postulates, during the last quarter of the past century, the advent of quantum information theory upends a new attitude towards this reconstruction program. Recently, researchers from S.N. Bose National Center for Basic Sciences National Center for Basic Sciences, Kolkata, an autonomous institute of Department of Science and Technology, established an intriguing result in this endeavor. Dr. Manik Banik and this group took the help of a novel information principle called the principle of information causality to see that kind of descriptions are naturally dissolved for composite quantum systems that include several quantum objects. Our recent research article published in Physical Review Letters proves that information causality plays a crucial role in selecting the quantum composite rule among different mathematical possibilities. In fact, information causality can discard a composition rule that is close to our classical worldview in the sense that the resulting theory will allow only classical-like correlations, Bell local correlations. This makes information causality champion over the other principles in deriving the mathematical structure of quantum mechanics. The World by Dr. Banik and this group from SN.
Now, our next segment is Analyst in STEM.
Today we are with Dr. G.U. Kulkarni, President, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru.
Could you please brief about the area of research that you're currently working on?
I have chosen a couple of areas to work in the area of nanoscience, nanotechnology. It's a very broad field. My expert area pertains to synthesis of nanomaterials, particularly metal nanosystems, and using them as active elements in devices. So again, it branches out into several sub areas. Broadly, nanoscience, nanotechnology.
Okay. How is your research beneficial to a common man or India as a whole? And what kind of contribution is it making to the field of science in India?
The kind of knowledge base these areas create, in fact, these are all global reach. Nothing particularly aimed for India. The nanomaterials what we make, let me give an example. The gold, conventional gold, what we make jewelries out of this gold, and we use gold plating. It's also used in electronic industry. It comes with one lattice form, that is face-centered cubic crystal structure. We teach our kids in the classes. In this lab, for the first time in the world, we have made gold into a different type of lattice. What happens when you change the lattice is change in properties. So the new lattice, what we have made in the laboratory, it does have gold atoms only. The difference is it exhibits a different set of properties. So gold is very popular, everyone knows about it, but our gold has very different properties. Simple example is conventional gold dissolves in aqua regia, but our gold doesn't, you see. Likewise, it doesn't form amalgam with mercury, it is quite stable. So likewise, it works as a catalyst. Conventional gold is simply very neutral in catalytic activities. So likewise, our gold is very, very different, and this has made global news.
Okay.
Now, when it makes global news, and including New Scientist and other journals interviewed me, we also brought out a lot of publications and a few patents. Local industries got in touch with me. Okay, whether we can mass produce, and actually they can utilize that in their coatings and jewelry and all that.
Okay.
We went up to a level of discussion, but there have been practical difficulties in translating it to and producing in bigger quantities and all that. So again, these are all research challenges, but you can see the reach now.
Yeah.
We create a new knowledge base, new invention, which has global reach, but it also attracts local industries. It also helps in developing local technology. This is just one example.
Okay. Being a commoner, I just want to ask, will the value of the gold change? Like, if the properties change, will its value change as well?
Of course, it depends on the utility.
Okay.
So when I have spoken to school kids about it, I keep telling that this should be at least 100 times more expensive than the ordinary gold. Just jokingly. Okay, going by the novel properties this gold has. But not necessarily. This is not a commercial price.
Okay.
It's just a sort of guess to excite the kids.
Okay.
But yes, the value depends on the abundance, availability, and also what applications can be derived from the material. They're all at the hypothetical level at this point of time.
Okay, thank you, sir.
But you want more examples on the invention? I can talk.
Yeah, the examples would be great.
Yeah?
Yeah, gold was very interesting though.
Yeah, sure. Take one more, please.
Yeah.
So this is, working with desiccating cracks. By the way, I just want to know, you're going to edit it anyway. Tell me, like time limits and all, isn't it?
It's like 15 minutes
in all?
Yeah.
15 to 20.
No, I will not take that much. So, let's talk about one more invention. This relates to the touch screen what you're using.
Okay.
Okay? The touch screen what you're using is of glass, of course, but it is electrically active. Because when you touch, it activates, it does something, right?
Yeah.
So the reason is behind this glass, there is an active coating which is electrically conducting. And electrical conducting systems, if you take, they are typically metals, copper, nickel, kind of thing. And even the physics says that when something is electrically conducting, it ought to be optically not transmitting. It has to be opaque.
Yeah.
And that's how copper, silver, they're all opaque, But the moment you bring in copper, silver there, you will not be able to use it as a screen.
Yeah.
You have to see through it and activate, right? So the challenge is to have glass, make glass electrically conducting, right? And there is one God-given material called ITO, let's not get into it. This coating is the one which is done by all industries on all optoelectronic devices.
Okay.
Any touch screen, smartphone, interactive TVs, anything you take, this particular coating is done. But there is one expensive element sitting there, that is indium, is as expensive as silver, which you just use and throw away your screen, so it goes, there is no way of recycling it, unlike the way you do silver. So the cost of the equipment is mostly to do with that particular coating. 1/3 of the cost goes for it, apparently. So with our nanoscience knowledge, working through our research, we have made some inventions. Let me talk about it for a minute.
Sure.
It comes from an altogether different angle. That is, how we can create fine metal meshes. Okay? Their presence itself you will not know because they are visibly not accessible. Very fine meshes. We produce them using certain templates. These templates are produced using what we call crackle lithography. Okay? So these are very fine colloidal particles. When we spread them on a piece of glass, as water evaporates, you find very fine cracks being produced there. This is a very common process. You see mud cracks, everywhere you see cracks, right? And when the rainwater goes away, you see cracks. When coffee water evaporates, you see the coffee powder forming patterns, right? Similar recipe, similar knowledge, but translated to nano.
Okay.
So these cracks are of nanoscale, length scale, right? Very, very fine, visibly you can't make out. So those tiny grooves, what get created because of the cracks, we fill them with metals. What metal? Not gold and silver. We fill it with aluminium.
Okay.
Right? Very, very inexpensive. And then we wash away the template. Right? We don't need the template. It's like, after all, it is very fine mud.
Okay.
It's inexpensive. So we are left with now a very fine mesh on a piece of glass. So it looks like glass only, but from one end to other end, it electrically conducts because it's a very fine metal mesh. So this is transmitting to the extent of 90%. Okay? Your touchscreen also does similarly. And it shows the resistance behavior very similar to what you get with touchscreen. So now comes the technology. Who are the buyers? Right? Many, many industries. We interact with many, many industries, and there are different stages, all the product developments, including through Indo-German Center in Delhi. We interacted with a German company.
Okay.
They translated this invention on a flexible foil.
Wow.
Okay, so and this flexi foil runs kilometers because they produce it with the plant, with the drum, with the roll actually, with this PET and all that flexi. So what I'm coming to is like, in our group we always strive hard to take any invention we do to the outside world.
Could you brief about your past, present, and future area of research?
I am born with nano.
Okay.
But when I started PhD, I did it with Professor C.N.R. Rao.
Okay.
And that time, the area was not known as nanoscience and nanotechnology. We just started working during PhD at IISc on very fine metals and looking at their electronic band structure and all that, structural details and all. And 10 years down the line, the whole area came to be known as nanoscience. And all. So I continue to work in that area. Okay. But my strength would be only around metals. And so globally also there has been quite a good amount of activity, but when there is a crowd, I move away from that. I choose my own tiny paths and try to select something unique and all that. That has made some distinction, right? And so we do have some global recognition because of this, because we take our inventions to the technology.
Okay.
Does it answer your question?
Yes, sir. Yeah. Do you have any idea about where India is right now ranked at in your field of research?
India as a whole has done very well, thanks to Nano Mission of the Government of India, has done very well in nanoscience. In fact, I would say for the kind of investment that was made, it has given a lot of returns. So in terms of publication, patents and industry interaction and human resource generation, in every aspect it has done very well.
Actually, do you have any idea like where India right now ranks in your field of research, like
Oh,
nanoscience?
this is very quantitative actually. Even nanomission itself did 2-3 years ago. India stood at a fourth or fifth position in the world
Wow.
in
Okay.
this area. Yes,
Nanoscience.
but we have a lot to catch up with because now this is diversifying into quantum technology, right?
Okay.
Nano is now the bedrock on which now quantum technologies are being born. Okay, new things are happening.
There are
We
several
have quickly we are actually missing out,
Yeah.
right? So we need to quickly catch up.
Okay.
So India may lose that rank, I'm afraid.
Okay. So it would be helpful if you share some information about your contemporaries as well.
Yes, given the nano umbrella, there are many practitioners from north to south and across. Yes. So you want me to name them?
A few.
Group?
And,
Okay,
yeah.
fine. So right here across in IAC we have the nano center, right?
Yeah.
So we have Professor Arindam Ghosh, right? He works with particularly the transport properties of heterostructures and many nano and quantum systems.
Okay.
Likewise, there are many colleagues at IAC.
Okay.
And then we have Professor George Thomas at ISET Trivandrum.
Okay.
He works with quantum dots and particularly looking at light matter interaction when the matter becomes very small. And very interesting results, and he's also earned good name globally. And Professor Pradeep in IIT Madras, he focused on very, very tiny clusters of materials and their assemblies and all. In fact, he also focused on the development of technology for water purification using nanomaterials.
Okay.
And his startups have done very well in the recent times. And he is globally recognized. He recently won a very big award, ENI award from Italy.
Okay.
And so likewise in IIT Delhi, you just visit any prominent, any of these IITs and all. There are people practicing. Even the other DST institutions like ARCI in Hyderabad, they focus on coatings and all. They come from powder metallurgy background and solar energy generation and coatings and all they focus on.
Yeah, okay.
And there are people in Indian Association of Cultivation of Science, right? So I can easily put down some 2-3 dozen names
Yeah.
who are doing in different
It's a
areas.
very
different areas.
glorified
That's right.
branch, yeah.
Yes.
So how are Indian industries associating with your research?
Yeah, just lukewarm. I have tried to interact with Indian industries, giant and small, medium scale and all.
Okay.
They are very conservative when it comes to putting their hands into innovative research because it is risky. Unless the industry has some background in R&D, it's not just about putting money.
Okay.
It's not about hosting some manpower. It should be a very strategic alliance. It should be that way. And many industries don't have that because they themselves don't carry out in-house R&D. Very few industries carry out in-house R&D. And many of them are also very conservative.
Yeah.
So often we have to look outside who could be helping all that. So, but recent years it has improved.
Okay.
Yes, very recently it has improved.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts.